Okay, so when you are setting up your beakers for the solution, you want to always have them just partially under that line so that when you stick your TLC plates in, they will not get to the bottom centimeter, but they will rise. And then you also want to mark all of your things. Since they're all clear solutions, you want to mark them with what they are.
A couple of examples of where we scan across all wavelengths for our unknown is 1, to get any of the values in our unknown, and 2, to get any max values in our unknown. Additionally, we use the Beer-Lambert plots lambda max, where the substance most strongly absorbs photons.
Awesome. You're awesome.
Okay, so when you're transferring water for your constant, you always want to use a pipette. And you don't want to go above the line, but you want to get to it for any of them.
Okay, so when you are transferring your solutions that you created, you want to put 2 drops into the cuvette, and then you want to dilute the rest of it with water.
Now we add 2 drops of our solution diluted with water.
The second color is blue. I'll add 2 drops. 1, 2. And then dilute it with water until the line.
Before starting, wipe 2 sides of the cuvette. Place it into the spectrophotometer. Close the lid. Zero out the scan with the constant water. Remove the cuvette. Place the first color cuvette in and run the spectrophotometer. Shown is the absorbance of the first color. Water was 0.015 and the color for 1 was 0.0185. Remove color 1 cuvette and move on to the mixed color. Wipe the 2 sides of the cuvette, place it into the spectrophotometer. Close the lid and record the absorbance. Remove the mixed color and move on to the second color. Wipe the 2 sides of the cuvette, place into the spectrophotometer, close the lid, and record the absorbance. Remove color 2 from the spectrophotometer. Here is an overview. Wipe 2 sides of the cuvette, place it into the spectrophotometer, close the lid, and record the absorbance. Then remove the cuvette from the spectrophotometer.
The overview of why we did all this, we were trying to find the absorbance of all the we were trying to find the absorbance of the unknown value, so we had to scan over all the wavelengths, and to do that we had to zero the spectrophotometer out, and then place our cuvettes carefully in there, and then we closed it, and then we obviously scanned it to get this kind of graph, and that helps us determine which unknown, what our value is on our unknown. Once you get all your absorbance for everything, you have to record it. So this was what we got for water, the first one, the second dilution, and then the third one right here.
When we're done, clean yo space.
So the variables that are in the Beer-Lambert plot, you have the lambda max, which is just where the substance is most absorbs photons, absorbs the most photons, and then you have that's absorption, and then you have concentration of your certain element. That's the 2 things that go into the max, the Beer-Lambert plot.
Remember to collect all liquid waste from the lab and put it into the waste container. It cannot go down the sink. The glass pipette from the lab must be disposed in the glass waste container. Remember to collect all trash and throw into the correct bin. Be sure to wipe down your area. Then, wash all glassware with soap and place into the cabinet accordingly.